thought is left behind with the kid and what inspires things where, and it's just getting a different perspective. And I think when the mind is more malleable, more flexible, getting these opportunities is, I think, vital. And all thanks to social media, and now even, I would say, so it's very difficult for me to see something as a negative thing. So I see COVID also as a blessing. It is forcing us to change. It's forcing us to remove barriers, which hopefully are not going to be dependent on the traditional barriers that we have. But again, things like this, I believe using technology for reaching out to people, engaging a lot of people, I think it's just brilliant what's happening out there.
Absolutely, absolutely. Our only thing is that, you know, once we are done with these sessions, hopefully we would have left something back for the students to kind of think through, you know, and look at their own pace and probably pick up some of these things at some point of time when someone's making a decision in terms of what do I do next, you know, how do I treat this? And there are so many learnings from a lot of such good speakers, right? And you don't know where it touches a chord, you know, so that's the most important thing.
Very true.
And, you know, to get a first-hand information from industry specialists like you in such forward technology areas and industries is, I mean, during our times, we didn't have this kind of opportunity, this kind of platform to have a first-hand information of, you know, I want to really pursue something passionately and I have here someone who is at it. Why not take insights into how the industry functions? So I think with today's day and age, children have choices, and if we enable the right choice, then it's like work done, you know.
Mm-hmm. No, I think you all are doing a brilliant job, and also I believe there is one thing you can discuss about it, you can read about it, but engaging yourself physically to engage with it, experiment with it, work with it, I think it's a much more better learning process. And what you all are doing in your organization is exactly that. And I think it has a lot of unexpected results, and those are the results that actually make a change on the planet. And I think you all are, you know, breeding grounds, incubation cells for this, and I think it's brilliant what you do. So kudos to that.
Thank you so much for that.
I mean, in fact, when we were growing up, we didn't have opportunities like you all. So it's great to see that at least the youngsters have the opportunities like you all and us nowadays to, you know, encourage that new thought process that they have.
Right.
So we've got our partner in crime also, which is Ashwin, right? So he's the owner of RFL, which is a very similar institute like us. So we actually kind of cross-leveraged our skill sets and said, let's go across and try to spread a little bit of more of for the STEM education, understanding, reaching out to students a little bit more cohesively. So that's Ashwin for you. And Ashwin, that's Dilip Chabria for you.
Hi, Dilip. Pleasure meeting you. And thank you for coming to this platform. And I'm sure we are going to have a very good talk today. And we are going to gain a lot of insights with your talk today.
I think I'll leave that judgment to, I would say 47 minutes from now and then see it comes. It's lovely meeting you, Ashwin. And I, likewise, I mean, what you guys are doing is very amazing. So anything I can do to help the younger minds, it's always a privilege.
Okay. Thank you. Thank you so much.
Okay, here we go. I think it's time that we start off. We want to hear more of you. So here I am introducing our guest, not that I really need to introduce him. He is Dilip Chabria, an electronics engineer from TSEC. Dilip recognized his true love for engineering successful companies, and for close to 20 years, he has been turning around businesses. He has an unbelievable track record of converting small organizations into recognized competitors in their respective field. He's a co-founder with Team INDUS. He's a co-founder at Blue Ocean IMC and an MD at Effective Media. He also works on space technologies, a technology that we can only dream of as of now, but he is in reality hands-on with it. So over to you, Dilip. We really want to hear more from you. And for all our children, parents who are listening to us, any questions during the session, please write it in the chat box and we will be more than happy to answer them. All right, over to you, Dilip.
Thank you so much, Ritu. So firstly is, I would love to say I would love to dabble with space things, but it is mostly my team and my fellow colleagues that do that. So I'm the slightly dumb guy in the room. So, but the team members that I have are just brilliant out there. So on the interesting title that Ritu sent me the other day, a space mission. So we've spent now nearly 10 years building out space missions and assets for the space missions here in India. And what I found interesting was I could actually talk about our mission, which would be one way of doing that. But I found that with the younger minds there, rather than talking specifically on our mission, I thought let's take them in a journey to start off and let's build our own new mission, right? So I don't know how many people are watching this, but let's assume that let's figure out what a mission entails and let's figure out the challenges that we have. So amongst the technicalities and the requirements, and I believe the keyword out there is challenges. I'll explain why okay. So I believe that there is hardly any activity on Earth that matches the unique challenges on space explorations. We really can't understand what are the real challenges on the ground in that happen in space unless you actually dive deeper to understand what these real challenges are. Because living here on terra firma, on planet Earth, we sort of lose out on understanding what are the harsh realities beyond this little bubble, blue bubble that we have, which we all reside on. So let's take a little interesting journey. Let's say we are traveling on an interplanetary mission, all of us. And so what are the stages of this mission? Purely speaking, it's broken down into 3 simple stages, which is you have to launch, you have to travel the journey or be in flight, and then you have to arrive at your destination. So each of these have interesting challenges, and I thought today let's take an interplanetary mission with all of you all, and then figure out that if we have to do these 3 stages, what are the interesting challenges that we would meet. So let's begin our journey. When you launch, one key friend, or so the beauty about gravity is it's a friend at times, and sometimes it's not so friendly also. So as we travel this journey, as we go through the different stages of our interplanetary travel and see what are the challenges we find, we will meet our friend gravity many times. And sometimes it is to your benefit, sometimes it is not, and then we have to build your complete mission around it and the assets around it. So let's understand this uniqueness about gravity. What we tend to ignore on planet Earth, we take gravity for granted. We are stuck on this planet, we walk around it. It's actually very consistent and constant. So we don't feel its play with us. It is constantly there and constantly affecting us with a very, very consistent, predictable force. And hence, we don't even realize that we are stuck to the surface of this round globe, which technically we should be falling off. But it's all because of gravity. We are stuck in place and we are walking around and using this planet and functioning the way we are functioning. Now, when I mean it is everywhere, it is not just everywhere on planet Earth. Here's the beauty. Anywhere and everywhere in space, you will find gravity available to you. So a force that is really readily available to you everywhere is gravity. Now let's understand, if you want to leave planet Earth, what you need. We need something called an escape velocity of 11.2 kilometers a second. Now, unless you can build that kind of energy and thrust, you're not leaving planet Earth. So that's where we come to. So what gives us those kind of thrusts? So we have something called rockets, right? So each rocket, now let's say we are going on a mission. The first thing we have to decide is what is the payload we are carrying? How big of a payload is it? Is it few grams? Is it few kilograms? Or it is a 500, 800 kilogram satellite, or a much larger 2-ton, 3-ton spacecraft that you're deploying. It depends. Now, all rockets can't carry the same kind of payload. So there are different payloads which different rockets are specifically designed to carry. And then again, to deploy in a particular kind of orbit. So there's a huge science that goes beyond which is the launch vehicle you're going to use based on your payloads. Sometimes you find the right launch vehicle and your payload is a little heavier. You need to then figure out how to trim that fat. So you have to actually put your mission on a diet and figure out what are the places you can lose the weight or design parameters and so on and so forth. So let's assume we got our payload capacity and everything right. We also need to figure out how much fuel you need to carry in that particular mission, because fuel also results into weight. So you just can't carry unlimited fuel. There is no HP or a BP petrol pump around the corner there where you can go and refuel. So you have to do all that planning. And it's not just the planning to the mission. It is if it's to and fro of the mission, and even you have to take into account any kind of eventualities. So all your spare surplus fuel, anything that you need, it all comes here. Now, obviously, one of the key things of leaving gravity is money. Rocket launches are very, 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 very expensive. In fact, that's the stumbling block in people going into space currently. But I think very soon we should be solving that for at least all the youngsters who are watching now. I think not too far away in the future, this challenge is going to get away. So currently what we're doing for our launch, and especially when we started our space launches, is it's parallel to you taking a car, driving from point A to point B, say from your home to your office, and then destroying your car. Now, if you do that every day, it becomes a very expensive journey, because the expendable should just be the fuel and not the vehicle. So currently all launches are, we actually expend the vehicle. And that is why these launches are so expensive. So if you see somewhere around the 1990s, the space shuttle, when they would deploy, the per kilogram cost used to be somewhere about $85,000 a kg to move from planet Earth to low Earth orbit. If you take today's current times, we are somewhere in the vicinity of $10,000 to $3,000 per kilogram. 3,000 being the other spectrum where you all youngsters would know about this company called SpaceX. Because they are not destroying their vehicle, you see their rocket boosters land back on planet Earth. They save a lot of money. So if you have a reusable aircraft and now spacecraft, and now everybody is focusing towards reusability, the cost is going to keep coming down. In fact, NASA and all the people who are working towards space exploration now, they find this is one of the biggest challenges that we have on the planet. And if we can move, and their ambition is to get our launch cost down all the way to about $100 a kg by 2040. So all you youngsters, this is the right time, right space to be in. If you're looking at things, there are going to be so many more missions coming up in the next decade. It's crazy, and especially when that cost falls down. And somewhere around the 2050s and 2060s, they're looking at building something called the space elevator. And all you do is, it's an elevator that travels about 100 to 200 kilometers up into space. And anything you put here leaves. So what happens, interestingly, is once you're beyond this 100, 200 kilometer distance from Earth, then even small thrusters can move you away. So this little friend we called, or not so friendly gravity, what I called, has been one of the particular reasons why human beings have not been exploring outside a lot. But I think that one of the biggest challenges, so if any of you youngsters love thrust, love rockets, this is the best time to be in this. This space is just going to literally, with no pun intended, explode. So rocket space is a good space to be in. But that's one of the challenges. So that's the first part of our journey, is we need to leave Earth. So I told you the major challenges right now are what you need to leave Earth. Now comes the other interesting challenge, space junk. The moment you leave Earth, we have an estimated about, there's a big minefield out there. We have an estimated more than 1 million plus pieces. So I'll draw your attention to a movie, Gravity. You saw those little, it was International Space Station being decimated because of these small flying objects. So we believe there are about 1 million plus such objects rotating or revolving around the Earth. They are the larger ones, about 10 centimeters plus, are about in the vicinity of 35,000 of them. And there are a lot of ground stations on Earth and a lot of space programs which are monitoring these tracks, and they're called dead tracks. And the moment you leave Earth, you are supposed to avoid this minefield. You have to plan your launch in such a manner that you do not hit any one of these. Now, why you don't hit any one of these? These are typically traveling somewhere at, and you're hearing me right, about 17,500 miles per hour. That's about 10 times the speed of the fastest bullet that you'll find on planet Earth. Yeah, so the 35,000 that you can track, you can probably build a program to work around it. But guess what? 35,000 is a very small number compared to the 1 million untracked ones. So you need to, the spacecraft or the asset that you're going to deploy, you need to make sure it has the right energy absorbing material on it, because these fast moving objects, even if they're very small, even if they're 1 centimeter in size, the amount of momentum that they have is crazy. So as you all know, mass into momentum is a lot of energy, and that's what you need to figure out. So there's a lot of research, a lot of challenges in figuring out what are the clear paths to leave from these minefields. And a lot of research and energy is taking place on what you call the materials that you can put around your assets, so that the smaller particles that you don't see are the particles that, if by mistake they happen to touch you, your body should be designed in such a manner that it can be absorbing at least a lot of that energy rather than destroying the asset that you have, right? So that's the first challenge that we will face, but that's not the only challenge. So let's see what are the other challenges. Oh, no Google Maps. Oh my God, now where do we go? So the interesting part of space is it is huge. We have this misrepresentation that our city is big, our country is big, our planet is big, but we are this very little dot. We are a very insignificant dot in that whole space out there. Now, once you look outwards, you start realizing that we take a lot of things dependent. So it's, as I told you, no Google Maps. Now, if you're up there and you need to go in a particular direction and you're going in the wrong direction, and as I said, you can only carry limited fuel, you can only do, so you can't get that wrong. Space engineering is all about getting, checking your problem, checking it right, understanding the challenge properly, and making sure you have worked on a solution and a backup plan and a re-backup plan on it, because you really can't, there's no failure in this. You have to work around it. So I'm not saying systems and all can't fail, but you have to have workarounds it. So you have to have your plan B and plan C and plan D. But the mission should be designed in such a way that the mission should not fail. Even if you have a failure of a component or a subcomponent or a subsystem, you should try to still be able to salvage the mission. So no GPS, so how do you move around there? So one way is atomic clocks. So you bounce signals and you see the signal back, and the difference in the atomic clocks can then tell you the distances and so on and so forth. But another one beautiful thing is there is that which we don't realize with our light polluted cities in the night, is there are amazing amount of stars there. And these stars are actually constant. As a location, they are more or less at the same place. Because they are such at far distance, they are a consistent spot in the sky. So our forefathers used to use them as guidance and navigation while traveling the oceans. And the oceans also had the same problem. You didn't know where you were. So you had to take the reference point. So we continue doing that in our space missions. So what we have is we call them star sensors. These are sensors that look at a particular star and align that. So we keep them in an XYZ direction. So we know at most times where we are based on this reference. And then we use the other systems to compute distances in between and figure out. So these are little challenges that you'll have. What you see next there is a sun sensor. It's a similar device like the star sensor, because just as you all know, our sun is also a star in our solar system. So we are very close to the star, and being close to the star, we need a different kind of sensor, which is, again, it's a consistent location. So we can take it as a reference point, and combining all these techs together, you actually start figuring out, you try to hope to do better than the Google Maps in accuracy and where you're going and what direction. Because here, if you're off by even a 0.01 degrees in the direction you want to go, the chances are you'll miss where you're trying to go. Okay, yeah, it is that way. There is a lot of research taking place right now, because the further you go from Earth, it becomes difficult to keep bouncing communication. Just to give you an idea, it takes, if you're communicating with an object on the moon, you would typically have a few seconds delay by the time the communication reaches there. Somewhere in the vicinity of about 2+ seconds would be the delay. And a similar delay would be there in you communicating back. So you would have somewhere about 4 to 5 seconds delay. And the idea is to avoid these delays, because the delays create all the challenges. So now further away that you start moving from Earth, dependency on certain systems, the accuracy starts going down. So there is a program that's being developed, which is called the Deep Space Positioning System. It will rely a lot on the imaging that the spacecraft is seeing at whatever point it is, and then use the image as a referral point. So for you youngsters, it is something like what a Google Lens would do. Look at a particular map or a piece of sky, and then you looking at that, try and extrapolate where in the sky you are in that 3-dimensional space. So this is another challenge, no GPS. So no point taking your phones along on the mission. It will not work. Then we have another interesting challenge. It's called radiation. The whole space is filled with a huge amount of subatomic particles. These are traveling virtually close to the speed of light. The amount of damage, as I said, we were getting a little worried about the damage that was being created around our space junk that we had. These particles are even more lethal. They travel at huge speeds. The kind of energies that they have, they end up creating secondary emissions. So they can probably hit your, let's say you have an aluminum sheet. It might hit your aluminum sheet, hit the atom in there, and force the nucleus to probably, I don't know, explode and create secondary emissions, which are even more powerful than. So it's not easy to take any material you want. You have to study all these different materials on planet Earth. You have to take space grade materials. These materials have to withstand a huge amount of radiation, or at least not be reactive to the radiation. So typically a lot of, let's say, lighter materials where their nucleuses are less to damage, atoms are less to damage, are taken so that these subatomic particles, or the radiation that is bombarded, the space radiation as we call it, does not start harming the material that we carry with us. For all you youngsters, the potential for solving this problem is force field. So like your Star Trek fans and all, you just turn on your force field. That's what we need. To tell you in reality, there is a lot of work and research taking place there. It is a sensible thing. It's like a magnetic field. It just deflects your smaller particles around, and you're kind of safe. So I hope that those kind of force fields are being developed by you youngsters very, very soon in the near future. But there's a lot of work taking place there, and just to solve up this challenge of radiation. Temperatures are very interesting in space. So I don't know if you all know something called absolute zero. It's the temperature at which all particles stop moving. The average space temperature is slightly just above absolute zero, somewhere around minus 455 Fahrenheit. When your space asset faces towards the sun, which is the hottest body closest to us right now, those areas can go 200 degree plus depending on where you are. So you could have one side of your spacecraft having 200 plus degrees and the other side running into minus 400 degrees or minus 200 degrees depending on what you're doing. So managing thermal flow on your space assets are very, very critical. It is nothing like what you have seen. It's like just to imagine if you're building a car, the front wheels of the car are in Alaska and the back wheels of the car are in the Sahara Desert. There are technological challenges for running a car on in high temperature versus cold temperature. And these are the extreme temperatures in which all space assets need to function. And it is not that they move from one side to the other. It's just that your left side could be at 200 degrees plus and the right side could be. So it is very critical to make sure that all your components and all which are temperature sensitive, they are kept away or kept in a direction where they can withstand temperatures during the journey as they're designed to do. Another interesting challenge that is there, and I put it down as a challenge, is the distance. We can travel a lot of places. So the beauty of being in space is once you move in a particular direction, so you have one of your Newton's law that functions that once, if you don't have any forces acting towards you and space has no forces acting towards you, you will perpetually move in that direction until something stops you. So that's the beauty what we have in space. We can travel very fast, very long distances. One of the fastest objects, just to give you a perspective on scale of things that's happening, is there's been a space asset called Helios 2. The fastest it has traveled, what I know of, I know very little about this asset, but I just heard about it. It's traveled somewhere in the speeds of, as I mentioned there, about 116,000 miles per hour. It's very fast speeds. Most assets that we travel with probably travel at half the speed of that. We probably would travel at about 40,000 to 80,000 miles per hour. But this space asset has traveled very fast. But to give you an idea, our closest star is Alpha Centauri. Even if we travel at those speeds of what Helios 2 has traveled, it would still take us about 19,000 years to travel that space. So, yeah, we still need to go faster. So all you youngsters out there, let's figure out faster engines, nuclear fission, all those kind of space age things that you're thinking of. Our traditional fuel-based technology or combustion-based technology is good enough probably for us to move in our solar system. But beyond that, we need something much, much faster. Again, I said we have to carry everything. And the question mark I had for gravity here is, I think he acts as a friend here. It doesn't stop us. It keeps us going in a direction we want. So what I told you, gravity you'll start finding coming everywhere. But the way he functions or it functions, don't know. Sometimes it is useful to you, sometimes it's not. So we actually use gravity during distances also is to slingshot ourselves. So there are times where we need to go in a particular direction, but we take the gravity of another close by planetary object to gather speed around, take an orbit around it and get slingshot into a very different direction. So in space, you'll hear about a lot of not a lot of, but you'll hear about slingshot orbits. Those are actually taking advantage of gravity and saving fuel to gather more speed. Now let's say we've got to where we want to go. We've reached our planet. Obviously, the first part of the mission of this stage is crashing is not an option, right? So You didn't travel millions of miles away just to crash, right? So that's not an option. So you have to make sure that your systems are all running fine. They're all tested. Now you're running at, say, 100,000 miles per hour speed. Landing at those speeds are not sensible. Your probabilities of crashing go up tremendously if you're traveling a very high speed. So now you have to decelerate. So how do you slow down? Again, our dear friend gravity comes in again. Now what we do is, what you see in the above image here is something called, we call it deceleration orbits. We take, your first orbit is actually the larger orbit, and we actually come down towards that planet. And if that planet has atmosphere, we use the friction of the atmosphere also to slow us down. But we plan and trajectorize the orbit in such a manner that it starts slowing us down. So every subsequent orbit becomes smaller and smaller till we come to a point where we are more or less having a circular object around the planet of interest. And then we start taking the other sets of maneuvers, which is the re-entry maneuvers. So if it has atmosphere, we start using atmosphere as a friend. We create drag, we put out drag shields, or at later stages, parachutes to start slowing us down. Typically, the front end of the spacecraft would be entering the orbit, but then later on, what you need to do is you have to maneuver it around so that your thrusters, now thrusters have to act like brakes. So you have to start utilizing thrust as reverse thrust. Again, you have to be vigilant that the place you're going to, you didn't have the road map there. You didn't know the exact location you were landing. Yes, you did from images, but what has come there? Is there a huge rock there, or there has been an earthquake there and it has opened up from the last image taken, and so on and so forth. So you have to be very careful of the terrain. You have a lot of sensors around you, which help you understand what you're doing, but you have to also be careful. There's a lot of dust while you're trying to land and use your thrusters. So this dust can actually become an enemy of yours. If you kick up more dust, your sensors become useless to you. So you need to plan out a lot of things. So space mission is all about planning, understanding, anticipating a problem on the ground, and keeping on figuring out ways of how, if any unforeseen problem comes, how you would work around these problems. I mean, trust me, the number of challenges you have, even just on dust, the challenges will be, there are different grades of challenges. All I'm just touching is the top level challenges right now, but these challenges keep getting interesting as you go below and below. For example, dust on the surface of the moon is very sharp. It is magnetic in nature, so it goes and sticks in places. So it just doesn't just come to you, it goes and sticks. It is actually very harmful for all your senses. So how do you work with that? It is very abrasive. So if it gets stuck between two moving parts, it can actually break that moving part, and so on and so forth. So a lot of interesting challenges are there in our mission. What I tried to do, if we did all these challenges and didn't get anything wrong, guess what? We would now be on the surface of the planet that you all ventured on going. So these are the few of the challenges that you face in a journey from planet Earth to any other planets that you imagine on traveling to. The other thing that is also an interesting challenge that we have to weigh out is why we need men in, sorry, with no disrespect to women, I'm using man as a placeholder for human beings. Why we need humans on any kind of mission is purely because there are a lot of on-the-spot decisions that need to be made. For example, a particular thruster is not working in the particular manner, and then we need to redo things, or there's an unexpected situation. Now, if you're very far away from planet Earth, your communication, let's say, might take minutes, if not hours, depending on how far you're away from planet Earth. You really can't, and especially when you're moving at speeds of 100,000 miles per hour, you really can't be affording to wait for a feedback coming back from Earth to reprogram something or do something in a particular manner. So you need human beings for on-spot decision making. their ability to understand a situation and work around it. They are trained to be very versatile. So they not necessarily do the job that they need to do. They need to fill in the gaps wherever they need to. So it's very difficult to make a machine that is very versatile. So hence you have humans there. We depend on machines on missions purely because they're very, if I need to get done anything in a precision manner, because things are moving very quickly there, everything is very fast, very quick, you can't make a wrong decision. So those are then put to the machines where precision activities are required. Their sensor accuracy depends on, what work they do is depending on the sensor accuracy, but generally now most of the sensors that we have on planet Earth are much better than our natural sensors that we have. Our eyes, our hearing, our capability of using all of our senses. I think we are teaching our machines to become much faster on each of these senses. And they're very much more reliable. They don't go through fatigue. They don't go through the challenges of space. Oh, I forgot. During this journey, while we were taking, let's say it is a 7-month journey all the way to Mars, you had no gravity on your ship. Your bones start having challenges, you get disoriented. I know we are all locked down at home because of COVID, but trust me, that space in the spacecraft is much, much smaller than your houses right now. So yeah, a 7-month journey, not seeing anybody else, not being able to talk, it can drive you nuts. So the reliability factor of humans can actually go down during journeys. So we depend on machines for it. And also in risky areas, unfortunately, but they are expendable. So this is how typically we decide on distribution of workload between humans and machines or robots that we use on our mission. So broadly, these are the challenges. I thought I would take you through this quick journey. Don't have much more on slides, but if you guys have questions, very happy to take them. A few pointers before I start taking questions is all challenges are great opportunities. I don't know if you all will get a chance. Space has been instrumental in developing a lot of technology that we use day to day. For example, our mobile phones that we use are, we call it a space spin-off. It's technology which is first developed for space, but then it has terrestrial applications. So technologies, most of the technologies that you find, so let's say your microwave ovens, your mobile phones, most of your technologies that are used in medicine for, so your heart monitoring machines, your breathing machines, your remote controls, your even simple things like your bifocal lenses that you wear on your glasses, or your scratch resistant lenses, or sunglasses that you wear. These are all technologies that have been developed for space. There are, I think, more than, I think 2,000 plus such technologies that we're using into our day-to-day life. And these spin-offs have been far more successful. So I think there is a saying, for every dollar that, or is it cent? I don't know. I don't know about it, but it's been far economically lucrative for planet Earth. So I think it's about, for every cent that NASA has spent on its space research, mankind has generated an economic benefit of about $8 out of every 1 cent being spent. So, so these challenges are great opportunities. You should keep looking at them. You should use these as trigger points, and any other opportunities or challenges in your lives as opportunities to actually create and innovate your own future. So all the best, and I'm happy to be grilled. Please go ahead. Let me know what I can do to help you all.
I like your last statement when you say I'm happy to be grilled, because actually there is a lot of material here ready to grill you, because they have a lot of questions. To begin with, you are the Elon Musk for India. I mean, where you're really working on a real space mission. Can you tell us?
That's a very different league.
Yeah, but if you can throw a little light on how and where, I mean, where does India stand in terms of launching their own missions? We've heard so much about ISRO, we've heard so much about Indian missions being launched. So where does India really stand from our global space technology, industry?
So very proud to say, ISRO is one of the leading space agencies in the world today. Definitely teams like Team INDUS would not be able to exist in this ecosystem if ISRO had not created the ecosystem that they have created. So any private space company today on this side of the world will definitely benefit from the efforts that ISRO has taken so far and is doing. So recently they have opened up the private space for private players, and they have allowed a lot of things. So a lot of testing equipment, a lot of knowledge, a lot of components, a lot of subsystems, a lot of, more than that, guidance. So there are a lot of people that we employ who are people from ex-ISRO. So the entire knowledge base, the ecosystem for developing space assets, that has always been, ISRO has been the torchbearer for that. And they have a huge, big heart. They embrace industry, and they allow industry to grow with them, and they allow youngsters to sit with them, innovate, and think with them. So your question being is, what are their missions? I think they are available. I'm not pit-pat on every mission that they have. They are planning human missions soon. They have multiple other missions lined up, and they're all very useful missions from human technology, knowledge perspective. And they work very closely with the international space agencies. So their programs are not in isolations. They take a lot of assets of other people other agencies whose probably missions are happening later, or there's a lot of collaboration between them. So answering is, I believe they have some brilliant missions, and they're definitely one of the leaders they're making a difference in the space community for sure.
Great. We hear a lot about space tourism, and we've heard tourism in various areas, but to believe space tourism in the next 4 or 5 years, we are waiting to see if it. Is there any fact that in the next 5 to 6 years we'll actually have space tourism taking place?
So can't comment on the timelines. That is dependent on the different programs that are there. Space tourism currently in this first avatar is going to be people going to low Earth orbit, feeling weightlessness, feeling the less effects of gravity, floating in space feeling. That will be probably for 10 minutes, half an hour. So I think the initial space tourism is just to go to the boundaries of our atmosphere, cross that, have a look back at our lovely planet, realize there are no boundaries between countries. It is just a seamless place. I think most people who have gone to space, their first realization is how fragile and how beautiful this system is. So it is for all of us, and especially the future generations, to realize this and build things around. But space tourism definitely, I think, is around the corner. As I told you, one of the key stumbling blocks right now, it is very expensive. I think those tickets to even take a 1 hour ride or half an hour ride in space, it runs into, if not $250,000, millions of dollars is currently is what I understand. But having said that, they're definitely going to happen. And for them to happen is, I think, directly related to launch cost. There are more and more launches taking place. The cost of moving somebody up there becomes lesser and lesser. We also weigh something. I weigh, I think, 75 kgs. So at least I have to pay for that much, or any other luggage or baggage that I carry. So I believe in the next 5 to 6 years, there are already missions in place to do space tourism. But I believe when the launch cost becomes consistent and the pricing comes down dramatically, like the $100 per kg cost, then I think there's going to be. So once you go in space, you need to go somewhere, right? So you need to build space hotels, things like that, where you can stay and all. So those also weigh. There is material to be moved. Again, subset of all launch costs. Launch costs come down. Somebody's going to build a business plan to put a hotel up there, put people to serve you there. And I think once that happens, tourism is definitely going to take place.
So this comes to my next question, which a student Isha is asking: what is the future of space architecture? Even though we have missions ready to go to Mars, when is it likely to see colonization at either Mars or on the moon?
So definitely, I mean, there are missions planned in this coming decade to Mars. Depends on the success of the missions. Colonization is obviously you'll have to. A lot of the missions to Mars is because we can only carry fuel for one way. These people have to figure out how to fend for themselves and live there. So there are plans for that also. Timelines difficult to predict. But will it happen in the future? Definitely it has to happen. Why? We live on a fragile ecosystem called planet Earth. We as human beings have to start exploring out, because if we decide just to stay in one place, extinction is always a possibility for us. So generally, species that don't know interplanetary travel are known to have, obviously we've not met any species and we are predicting, but science shows that if you don't do interplanetary travel, the chances of extinction go up much higher. So Isha, if you work harder, get your friends together, force them to start looking towards Mars, I think those missions will happen faster, and maybe we'll go and start staying there in at least my lifetime. So let's see.
We have another student, Krish, asking, can dark energy affect space exploration?
There's not much known, Krish, on dark energy, and I know a Krish out there who's building out some small sats, so I hope he's not trying to make me look on this chat. So if he is, I think I have to write a letter of recommendation to him, so that's still pending. So
all right, I have another student.
Let me answer that. Dark energy has a huge impact. What it is, we don't know currently. So there's a lot of studies still taking place. We know very little on dark energy right now.
Okay, another student asking, which industries will play a major role to support and endorse space exploration? This is from Siddharth.
There's everything, any kind of engineering industry, any kind of tech now. In fact, people are doing, pharmaceuticals are looking at space industry active. I don't think there's any industry that's not looking at space, because the next generation of medication that you want to build, what you can do in space, you can't do on planet Earth in the absence of gravity, and so on and so forth. There are a lot of things, a lot of industries, but definitely engineering industries are definitely the mainstay. As I told you, all the challenges which we went through, from launch industries to industries making specialized material to industries working on anything that you want to work on, radiation, creating lighter materials, creating the right tech to understand how to navigate the minefield, and so on and so forth. There is the opportunities are limitless there. But right now, they're all engineering-based companies, and now a little pharmaceutical companies. But as we spoke in an earlier question, space tourism is around the corner. As Isha mentioned to you, you're going to go and colonize Mars, so mining activities will also start. Don't know. It's limitless out there. But yeah, all STEM-based activities, and that's where, sorry, Ritu, that was an area I sort of slipped out, but STEM and space are entwined. You can't do space without STEM. Definitely the engineering, the math, it is very, very precision oriented. The reason we as Indians have been doing space for a long period of time is because of our strength in our mathematical knowledge, our precision knowledge that we know. So if this is an area that excites you, STEM is somewhere you have to get your hands a little dirty.
Great. So we have one more question. What are the pathways for students to showcase their ideas and try getting into a forum where their ideas are discussed and given platform for further improvisation? This is from Kunal.
Kunal, you use a lot of long English words, which I hope I can do a little justice to answering. I think there are a huge amount of forums. So I would say it's more than anything else, it is your own initiative. I believe industry is open to youngsters walking up to them and saying, hey, you know, we're planning to do this, or I think we can do this. Would you like to hear us out? So that is one way. Obviously, there are competitions taking place. There are people whose organizations are designed to inspire and see your ideas and move forward. So I think industry and today even education forums are open to, and even governments are open to seeing ideas. I think it's your own initiative. Don't get discouraged if you get 10 people to say, I don't like your idea and it doesn't work this way. Believe in yourself, believe in your dream. Trust me, I mean, it might sound a little corny, but we all get dreams and they're very vivid. And I've never heard anybody's dream being, I want to be second best at something, or fourth best, or I want to turn to be the 8th fastest swimmer, or whatever it is, right? The dream is always to be best out there. And I think it's some form of communication. It's the universe's way of trying to talk to you and tell you you're really good at that. The beauty of your having ideas is everybody doesn't have to be appreciative of an idea. You just need to find that one right person. So find that needle in the haystack. Where is that needle? Don't know. It could be in the industry. It could be, reach out to people. Worst case, they can say no. So fine, no problem. As long as you're willing to knock one more door than the number of doors that shut on you, trust me, you'll find your answer.
Great. I have another student, Hamdan, who's asking, which is the best place to study space technology?
Best place, it depends what you want to really master at, but the leading country in the world doing a lot of space research, which has a lot of education programs around it, is the US right now. So you should look at the programs that they have there. They would be great. ISRO also has some platforms. I'm not really clear on what they have, but they have, they're good at what they do too. So you should look at these programs. So some of the best minds we have in our organizations, they come from India and US, from different institutes here and there.
Okay. Any other thoughts for these young minds in terms of, skills that they should develop, or readings that they should do for them to be more upbeat in their knowledge for this new industry that is really growing, which is space technology?
I would say it works for any industry. Reading, I think read whatever you enjoy. So I think the first, so we call it the battery in the human being. If your battery is discharged, it doesn't help, but the battery in you is your passion. If you're really passionate about something, follow it. Yes, you'll get a lot of people saying no to you, but trust me, the reason you get passionate on subject is you have this limitless source of energy in you. There's nothing wrong in having a limitless source of energy. The only thing wrong in it, it has an on-off switch. If you're not passionate about something, then you're switching off this battery and it's of no use. So first, figure out what you're really passionate about. Second is, again, if you want to come to space industry per se, there are a lot of different companies and different areas where they're growing. Again, it's linked to the earlier thing, go into a good program, study a good course. It will get you to great areas, but don't forget to follow your passion. I think that's the key thing. Why passion again? And if I can take a minute more there. Once you're really passionate about something, you have the power of not giving up. I think dreams only fail when you give up. Again, there's a big difference between failing and giving up. Okay, failing is a learning opportunity. We fail all the time. We fail all the time, and it's a regular area in any kind of industry where you're working on a cutting edge technology. Failure means you thought it would end up being doing this. It's not doing that, right? So you wanted to build, let's say, a rover, and you decided that you programmed it that it should, after traveling 1 meter, it should then turn for 10 centimeters on the right side. It didn't turn right side, it turned left side. That's a failure. Now you learn from it, right? Give up is when you say, oh my God, I can't do this. Okay. So failures are very much welcome. Failures are actually teaching opportunities, learning opportunities. Keep doing that. Keep failing. No problem. Parents, if you're listening to this, I'm sorry. I don't want, I know you will get this thing that I heard that conversation that said that failing is fine. Failing, as long as you're learning from it and not, and making another attempt to go back at it again, not giving up. Okay. So keep that in mind. So passion helps you make sure that any kind of failure turns into a learning opportunity. So utilize that. Don't forget to do that.
I think, Dilip, this entire presentation has been very simplistically put, but so profound in its thought, right from the basics to the gravity of how important each of these basics is so wonderful. Like you've been saying very modestly that I've put little things together, but they are, they give you a complete perspective end to end in terms of um, the big decisions, and so many in each of those that you need to really take care of with something so huge. And various information like $100 per kg, and I can imagine 20 years from now we can own our own space shuttle if the cost comes so low. There'll be many who would want to do that. So
You forgot, after that, your space elevator is coming. So that's probably going to be $2. That's going to be $2. So
wow, I mean, for us, these, and then when you said that there is deep space imaging, there is so much of radiation technology, and in each of those, the sensors that get spoiled because of the magnetic condition on moon, the dust condition on moon, it is so much that you can just keep researching, learning, researching, learning. There's no end. It's like as big as space can be. So thank you so much for enlightening each and every kid and us on such a beautiful topic of space. Thank you very
it
much.
was a privilege to be here. So thank you very much. Just as a parting thing, I forgot to bring that up, but I think these hands-on experiences that you all do definitely encourage something called teamwork. It would be, and as our name says, Team Indus, you cannot build great things in life without having a great team. And learning how to become a great team member only happens is when you get into real life scenarios. I would encourage you, get few people together who have the same passion with you, the same vision with you, and start building things, start creating things. Don't worry, if you hit failures, get up. So if you stand up one more time, the number of times people trip you, guess what? That's the formula for success. So keep doing that. Good luck, everybody, and all the best.
Thank you, Dilip.
Thank you.
Thank you so much, Dilip. Thanks for being here. Thank you all. So for all the children who have attended today's session, we have our guest, an expert coming for another session tomorrow. So keep looking out for this space. 6 to 7, we'll meet again with our other expert giving you insights in another good industry. Thanks, Dilip. Thank you so much for being there. Thanks.